Okay, good morning, class. We are already late one chapter from the other class, so I'm sorry. I'm going to speed this up. If it's a bit too fast, please tell me by raising your hands and ask questions. You may put it in our Zoom chat or our line group, okay? Um, since this topic will be in your exam, don't forget to please review the topic after we have finished our class. I'm going to start our topic. By the way, our topic is about wave. If you have heard from the other class already or tried to ask them, yeah. So we are going to start wave. What do you guys know about wave? Do anybody want to answer? Does anybody want to earn some recitation points? All right, so we are going to start with the table of contents first. First, there's the overview and definition. Second, there is types of waves. Third, the classification of waves, and fourth, equations and examples that I'm going to show you. So first, wave. What is wave? Here you go. The definition of a wave. Waves are produced by disturbing a medium as oscillation happens to transfer the energy from one point to another. Moving on. We are going to the parts of wave. So as you can see here, this is compression. Compression is the part where it's more compressed, and the more longer, not compressed part is called the rarefaction. The rarefaction and compression will make one wavelength. It will make one wavelength. And that's for the longitudinal wave. And for a transverse wave, a crest to another crest is going to make a wavelength, or from one through to another through. That's also going to make another wavelength. By the way, through is the lowest point of a wave, crest is the highest point of a wave, amplitude is the height from the wave to, does anybody know what is this line? Okay, it's called the equilibrium position. Make sure to write that down in your notes because it's going to come up in your exam, which will be held this, I forgot, but it's near. So be sure to study, guys. Okay, and now that we have the equilibrium position, amplitude, wavelength, crest, and through, compression and rarefaction, and that is all for the parts of a wave. Before I'm going to clear my drawing, please screenshot if you want to screenshot it. I'm going to clear it right now. And we're going to move on to the types of waves. Guys, if I'm going too fast, please tell me, yeah, so I can match up my speed. We're just a bit late from the other class, so I gotta make it up, you know. The types of waves. We have longitudinal wave and transverse wave. Longitudinal wave is a type of wave whose direction of oscillation is parallel to its propagation, while transverse wave is a type of wave whose oscillation is perpendicular to its propagation. As you can see from the pictures above, it is like that. And moving on, classifications of waves. There is 3 classifications of waves. There's the mechanical wave, electromagnetic wave, and standing wave. Mechanical wave is a type of wave which requires a medium to propagate. Example is sound wave. And second, electromagnetic wave, or we call it as EM wave. It consists of 2 transverse waves, one with electric nature and the other with magnetic nature, which are perpendicular to each other and can still be propagated in the absence of a medium. Third is the sounding wave. It's a type of wave which is propagated in the form of a musical system. Example is a guitar string. or any other musical instruments. That is the drawings for so that you guys can understand about it more. Don't worry, guys. I'm going to share this PowerPoint with you so you can review it in the house. That's mechanical wave, that's electromagnetic wave, and that's for sine wave. Moving on. This is a wave function. The equations that we are going to use for solving an example later. By the way, do you guys know what is the difference between sine and cos wave? I see no hands raised. Okay. So the sine wave is this red line, okay? A sine wave starts from the bottom, while a cos wave will start from the top, the blue line. So the difference is from the point that they start in, okay? Number 4 is the formula and examples. Like that, guys, you don't have much time. This is the formulas and this is the definition. B is wave speed, this is wavelength, F frequency, T is period, the W with not like that is angular frequency, K is wave number. Don't forget to write all of this down in your notebook, guys. Okay, this is the example. I have put the finished example in solution in this place so you guys can review it, but right now we are going to discuss on it together. Let's start. A battery operated toy boat is floating on a float. Boy controlling the toy boat notices a wave crest passing every 10 seconds. He estimates the distance between wave crests to be 8 meters with an amplitude of 0.045 meters. A. What is the frequency? Let us start with A, okay? Sorry, guys. Get my pen. A. Frequency. Does anybody remember what is the formula for frequency? It's 1 over period. And the period, as you can see here, is the time here, okay? So that is T. So it is 1 per 10. What is 1 per 10? It means it's 0.1 hertz. Okay, that's for A. B. What is the speed of the wave? Speed of the wave is V. Symbolized as V. V is wavelength times frequency. So wavelength is 8 meters times the frequency, which is now 0.1. And 8 times 0.1 would equal to 0.8. And that is for B. Meter per second. Now C. What's the angular frequency of the wave? Angular frequency is 2 pi times second. So it's going to be 2 pi rad times the frequency, which is 1 per 10. 1 per 10, so 25. So it's going to be 5 per 5 rad per second. That's C. Now we are going on to B. How much rad per meter of wave passed as observed from the boy? So that is x of the k. What is the formula for k just now? It's 2 per wavelength. It's going to be 2 pi rad per wavelength is 8. So it will be 5 per 4 rad per meter. This is rad per meter, yeah. And then now we are going to the last question, which is give the equivalent vertical displacements y using cosine wave function given x is half of the wavelength and t is the period. So first of all, given x is the half of the wavelength. Wavelength is 8. So half of 8 will be 4. So x will be 4 and t is the period. So t will be 10. We need to identify the given first, okay? And a cosine wave, what is the formula for a cosine wave? It is y amplitude times cos. Inside will be k times x minus rad. Now we're going to put the numbers in, which is 0.045 times cos k. K is pi per 4 rad per meter. Pi per 4 rad per meter. Pi per 4 rad per meter times x will be 4 meter. So meter and meter will cancel. 4 and 4 will cancel. It will leave us pi rad. It will leave us pi rad. Sorry, using a mouse is kind of hard. And then now minus w, which is pi per 5 rad. Pi per 5 rad per second times the time, which is 10 seconds. 10 seconds. Seconds and seconds will cancel. 10 and 5 will cancel, becomes 2. So pi rad will be minus 2 pi rad. Okay. Pi rad minus 2 pi rad will result into negative pi rad. And 0.045 cos negative pi rad. Let me just move this part first. Okay, let's do it. Just going to erase. It's okay if I'm going to put this a bit downer, yeah. Sorry guys. There's not enough space. Negative pi rad will be equal to a negative 180 because 1 rad is 150. Okay. 150 cos negative 180, 0.045. So it will be like 0.045 times cos negative 180. Negative 180 will become negative 1. So the end result is negative 1 times 0.045. So the end result will be negative 0.045 meters. And just circle this. And that is your answer for E. Okay, is that understood, guys? I'm going to clear this panel now. Screenshot if you need it. Okay, I'm going to clear it now. Okay. Okay, that is the end of the PowerPoint. Okay, guys, I hope you guys understand. Don't forget to revise for this topic, and I'll see you next time.